Hello everyone, stop doom scrolling and let's start finding the maximum sum of distinct elements with a length k. So it's a question that will solve easily by a technique called sliding window plus hashmap. Why sliding window? Because we have a window given of length k. Why hashmap? Because we need to check that every element in that length k should be distinct. So we need to keep account of the number of occurrences of that element, hence in hashmap. So now let's do it right into making you understand how sliding window plus hashmap works on this question. So we'll just start by giving j and I pointer to the first index, and we'll keep an answer in some basically started as 0, and then a map to keep the count of check of the number of elements. Okay, so we'll start with the first element. So j going to traverse through the array. So the j pointer goes to number 1. Occurrence of 1 is 1. J pointer moves forward over here. Now occurrence of 5 is 1. J pointer moves forward. The occurrence of 4 is 1. Now j minus I plus 1 is equal to the window size k. So now we have reached the window size. Now we'll simply do answer is equals to maximum of answer comma j minus I plus 1 if it was the length of the subarray that we need to find, but here we need to find the maximum sum. So we'll take the current sum, which is 1 plus 5 plus 4, which is equal to 10. So the sum and the answer the maximum would be 10. So hence we'll put answer is equal to 10. Now, when you reach the window size, you know that when you move to the next element, the window size would increase. So what we'll do is when we reach the window size, we'll just move forward the I pointer once after calculating the answer. So now we'll move the I pointer once forward. So now the sum will reduce from 10 to 9. Occurrence of 1 will go from 1 to 0, and the I pointer would come over here. Okay. Now we move j forward. Sum goes to 11. Occurrence of 2 is 1. Answer is maximum of answer comma sum, which is 11. And we again move the I pointer forward. So sum goes down to 6. And yeah, the occurrence of 5 is also back to 0. They move j forward, j goes to 9, so this is 15, and occurrence of 9 is 1. Answer is maximum answer comma sum, which is now 15. Now we move the I pointer forward, so we reduce the sum back to 11, and the occurrence of 4 also goes back to 0. So now we move j forward. Now occurrence of 9 is already 1. Occurrence of 9 comes to 2. Now in this scenario, when we have repeated characters, we need to move the I pointer forward till we do not have a repeated character or a repeated number. Okay, so we'll continue moving I forward. The sum goes to 20, by the way, currently. But now that we have a repeated character, we will not check for the answer. First, we'll move the I pointer forward. The I pointer goes from 2 to 9. So the occurrence of 2 goes from 1 to 0, and the sum reduces to 18. And now the number of occurrences of 9 is still 2. So we need to move I forward once more. Now the occurrence of 9 becomes 1, and the sum goes down to 9 from 18. Now we again have all distinct elements. But now this number of elements in the window is not equal to k, so there's no need to check the answer really. So at the end of the day, the answer turns out to be 15, because once you again push j forward, the number of occurrences of 9 would become 2, and then you move either I pointer forward again till only if there is one occurrence of 9. So at the end, the maximum sum of the array with distinct number of k elements is going to remain 15. So that's how you solve this question using a sliding window plus hash map. The time complexity of this question is big O of n for the sliding window, and the space complexity for the map is also big O of n. So that's it for this video. Meet you in the next one.